Here's our summary. Chapter 1. It is an introduction to the situation of sub-Saharan Africa, including its lower GDP per capita, productivity gaps, and volatile economic growth. Chapter 2. It indicates sub-Saharan Africa was left behind by some countries who had similar levels of inputs and outputs half a century ago. The main reason behind it was the inefficiency in the factor production. Chapter 3. It tells us how institutions and economic policies distort the decision-making of production and the productivity in sub-Saharan Africa. Today, we're going to focus on how to measure the productivity and the main drivers of the productivity gaps. Let's start the video.
So basically, I'm here to explain how do we measure the evolution of productivity over time. Productivity evolution trends are documented on an aggregate, sectorial, and establishment levels, which benchmarks productivity levels and growth in sub-Saharan Africa in relation to other countries. From the aggregate level, the level of productivity in sub-Saharan was approximated and compared to the international benchmarks, such as the US in this context. Labor productivity is measured by the ratio of real GDP to the number of people employed. Here is a graph illustrating the output per worker in sub-Saharan Africa and EAP5 countries. We can see from the graph that in 1960, workers in sub-Saharan Africa were about 40% more productive than those in the EAP5. In contrast, workers in the EAP5 were 3 times as productive in 2016. Therefore, by estimating the level of growth, we are able to conclude a significant decline in labor productivity over time. In terms of the sectoral level, input-output data, the United Nations National Account Database, and International Labour Organization statistics was used to measure the difference in labor productivity across distinctive sectors. Here is a diagram showing the sectoral labor productivity relative to agriculture from 1990 to 2016. We can see from the graph that the labor productivity is lower in agriculture than in the region's non-agricultural activities. From the establishment sector, the data from World Bank's Living Standards Measurement Studies was used to assess the total factor productivity quantity and the total factor productivity revenue. Here are some diagrams showing the quantity versus revenue productivity across selected sub-Saharan Africa countries. We can see that all curves are upward sloping, indicating a strong positive correlation. By taking log to both TFPR and TFPQ, we are able to derive the elasticity and productivity by making comparison.
So what are the problems of these data collected? Many countries' national statistical systems are trapped in a vicious circle, where inadequate funding undermines the production of high-quality data. And due to the lack of funds, many statistical offices in less developed countries still use outdated methods and data, which is lack of adherence to international standards of national accounts measurement. And as a result, economic activities including non-monetary, subsistence, or informal sectors are all unrecorded in sub-Saharan Africa. This plays into the question the reliability of the reported data on labor and income. What's more, a lot of new industries are unmeasured and not included in the economics in the past years, which are chosen as base years. For example, firm production, information technology, and telecoms, etc. This makes the calculation of change in productivity and output in a country much more unreliable. And there are other problems. Output and productivity estimates across African countries can also be volatile, not only because of the low quality of statistical services, but also partly because of the large weight of sectors, such as agriculture as seen on the first picture on the right. Low and middle income countries depend more heavily on primary and secondary sectors, as taught on the class. These sectors are prone to volatile domestic shocks and vulnerable to fluctuating international commodity prices. And secondly, the total factor productivity revenue. It is usually defined as the ratio of firm sales or revenues to input costs is one of the most widely used measures of firm-level productivity. And of this TFPR, there are two problems. So first, revenues of each firm vary across countries, and this can be due to different prices in each country. So it has been argued that TFPR is a measure of profitability rather than productivity. And secondly, rise in TFPR caused by rise in firm sales can be caused by rise in demand but not fall in input costs. So the rise in TFPR is not caused by higher productivity or technology efficiency, Sometimes this is not distinguished in some poor countries, so there is overestimation of evolution in firms' productivity.
I'm going to talk about another topic which drives our interest, that is, main drivers of labor productivity gaps between sub-Saharan Africa and the US. Let's look at these capital stock changes of US and Ethiopia, a representative country from sub-Saharan country. And we find that in 1960 to the mid-1980s, US had on average $20 million of capital stock, which is around 100 times than that of Ethiopia's 30,000. And here is a data analysis of labor force in these two countries. On the left, this is the growth of working age population of US. The graph below is the participation rate of the US. From this, we can estimate the labor force on average of the US was nearly about 76 million. By dividing capital stock by labor force, the capital stock per worker of the US was then 0.26, while Ethiopia's was only around 0.002. The capital stock per worker of the US was nearly 100 times of Ethiopia's. This is a huge difference. Then, we can conclude the main driver of productivity gap in 1960s to mid-1980, which are undercapitalization and lower relative accumulation of capital. And sub-Saharan countries' relatively low capital output ratios and limited human capital are also evidence for the productivity gap. By applying the production function, we can get this production model. The curve in the graph shows the production per worker with respect to the capital per worker. Since US has a higher capital stock per worker, that is K1, than Ethiopia, that is K2, the US has a higher point and a higher corresponding output per person, which is Q1. If we assume US and Ethiopia workers have the same working hours a day, labor productivity of US is clearly higher than that of Ethiopia. And now let's look at the period after mid-1980s. We have this observation. Disparities in labor productivity between sub-Saharan Africa and the United States were larger. Undercapitalization still plays a role in disparities of productivity, but the main driver is now TFP. Let's look at this production function again. A is what the TFP stands for. A large difference in TFP will make a huge disparities in output per person. However, we then find that TFP plays a larger role than what we thought. It even leads to the internal productivity gap within sub-Saharan Africa, and this seduced our further research.
So here comes to a problem. Why there is a large gap in sub-Saharan Africa? The distorted resource allocation is the main reason for this gap to exist. The distortion in resource allocation across the different production units which affect the quantities they produce and the economy's aggregate level of output and productivity. The reason this happens can be divided into three reasons: the credit market imperfection, the lack of land titling, and the information failure for firms in the market. Here are some evidence of misallocation that I found from both Malawi and Ethiopia. There is a significant lack of market land resources, even though government try to solve the problem. It doesn't work so well. The table 4.2 showed that the efficiency gains is large for farmers who run land. The data refers that the land markets are still limited, even for farmers with access to marketed land. They are still way far from their efficiency scale. From table 4.3, we can see that most of farmers are operating on less than 2 areas of land, but the most productive farm should operate on almost 6 areas on average. The actual distribution of income and productivity is widely dispersed despite the relative equalization of input across farmers in Malawi. For example, the ratio of the top to bottom quantile of agricultural output is a factor of 34-fold, although the corresponding ratio of the top to bottom quantile for capital and land use are within a factor of 1-fold to 2-fold. In other words, equal access to land across households does not necessarily translate into income equalization because these farmers differ substantially in their productivity.
That's the end of our video. Thank you for your watching.